You will die soon. You will die
I will
soon.
die.
You will
I
die
don't know why
soon.
I'm laughing,
You
but
will die soon.
one
You
subscribe
will
is
die
equal to
soon.
one pray
You
for
will
me.
die.
So guys, welcome back to X Drawing, and today we are going to do something new and crazy. We are going to predict if we will die with a heart disease or not. So for doing that, first we need some data, and we are having the data. As you can see here, we are having a data which is having some variables. Definitely age, anemia, creatinine, diabetes, ejection, high blood pressure, and I don't know what is this, this serum, and what is this. So basically what we need to predict is we need to predict the death event. If one means the person will die, or with zero means the person will not die. As you can see here, the number of ones are greater than number of zeros, and actually we will identify it in a notebook, but right now, as you can see the data, we are having some columns and definitely that event. Without any delay, let's jump into our Jupyter notebook. Okay, so we are using the VS Code IPy kernel notebook, or anything, whatever you want to say it, but it will replace the Jupyter notebook, yeah, definitely. And you can also use Google Colab, and the data link is in the description. Go to GitHub and download the data, so you can use the data in Colab, or you can use the data offline, right? So I'm having the data which is heart failure clinical result. So now I'm going to make a new file as a new.ipy and nb. I think this is the, yes. So it is connecting to the kernel which is Python 3, but I need to connect to the kernel which is a TensorFlow. So let's choose that kernel. Here it is. Yes, switching kernel to TensorFlow, we are connected with our TensorFlow kernel. First we need to import some libraries so we can import our data and do some visualization stuff, but this video is for beginners, so yeah, we are good to go. Import pandas as a pd, and you can import cborn. Import a cborn. It's basically a data visualization library as SNS, and you can import matplotlib.pyplot as plt. Let's run this, and the data libraries are imported. Now data frame is equal to pd dot read csv, so we can import our csv file which is heart, and this is not auto completing it, so let's copy the path. .csv and df.head. Yes, here it is. So we are having our data as age and all the other stuff. So let's visualize the data. So for visualizing, we need to find like if there is any null value or not. So you can find out by saying df dot is null, and definitely you want to do some of it. There is not a single null value. You can see here is 0, and so all the columns right here, and you can see the integer value 0 in front of all the columns, which means that there is not a single null value. And how many values we are having, how many rows we are having in our data set. So let's say sheep, we are having 299 rows, which is not a huge data set, definitely. So we need to do some traditional machine learning algorithm instead of using some deep learning ANNs, right? It's time to figure out some correlations between some columns, right? So figure plt.figure, we are going to set the fig size is equal to 12,4 because figure is going to be huge. sns.heatmap and df.correlation, because we are going to map the correlations of the data frame into the heat map of cborn library, and a0 is equal to true, so we can see the values. And here it is, you can see the values right there, and what are the values, right? That event, so basically that event is correlated to time. As you can see, minus 0.53, which means 50% in negative. It is correlated to time, and definitely it is correlated to age. As you can see here, 0.25, and yeah, so definitely we are having some correlations, which is a good thing to predict some correct predictions, right? We need to find like as you can see here, the data is correlated with age, right? So we need to visualize the age column more. So again we are going to plot a box plot. So fix the figure size as 12,7, and here you can say sns dot box not boxen box plot, and in box plot you can say df death, and it's not auto suggesting me, I don't know why, event. And also in y we are having a df. In the y-axis we need to have age. We'll see hue later, but right now as you can see the figure is too big. Let's say 10,5. Yeah. So here you can see the person which have died due to heart failure are of older age than the person which have not died, right? The mean and other thing. Now we know that age is something we need to look for, and the other thing that you need to look for is definitely the other thing is time, and we are going to visualize time. But right now we are going to see like if it is dependent on the blood pressure or not. df, and I think I need to copy this thing. Okay, right here you can see the blood pressure is not that dependent on that event, right? And you can see it here also. Where is our that event, and where is our, what is this, high blood pressure, right? So high blood pressure, and that is 0.079, which means only 7% it is dependent, so it's not that much. Okay, so now we need to visualize some more information, and after that we are going to train our model. If we are having some connections with diabetes or not, right? And what is the name of that column which are having diabetes? Where it is? Okay, it's diabetes. Yeah, diabetes is also not affecting that much, right? These are not the important columns that we have to look for. Now we can move from that thing, and we can go and find out like what is the mean of diabetic persons right there. Count plot, we need to like count the number of diabetic persons. It's going to be that event, and hue is equal to data frame, and I think, yeah. So here's the plot. The mean is kind of equal, like it doesn't matter if the person is having diabetes or not. The person, like here's the mean is also equal, and here's the mean. Let's find out the mean. What is the mean? Let's say df dot group by, and group by diabetes, and dot mean, and mean we need to find out the column of death event, and we need to plot it like kind is equal to bar. Okay, so the mean is equal, and only 0.1 kind of difference we are having here, so it's not much more difference. As you can see, the persons who are died are also having diabetes, and the person who are not died are also having diabetes in the same ratio, so the mean is equal. And it's kind of great thing, like diabetes doesn't affect your heart failure, but in real life it affects. So the data is not real. I don't know about it, but I think the data is real. As I have seen the information of the data set is real. So sns.boxplot. Now it's time to see something from the time, right? We are having the time here, and which is the highest which is having the highest correlation with our death event, which is minus 0. Which means 53% of correlation it is having. X is equal to df, and death event, and y is equal to df time, right? Yeah, you can see the difference clearly. The mean of that thing is 50, and the mean of that thing is is about 175. So the death is directly dependent on the time. I think inversely dependent on the time. So we are having our all the visualization right here, and we are finished with our data visualization and data pre-processing and feature. Like we haven't done any feature engineering right there because it doesn't require. It was not required. As you can see, the all things we are having are fine. Right now, let's import some stuff from sklearn.preprocessing. Import min-max scalar, and also from sklearn dot model selection import train test split. Also from sklearn dot matrix import confusion matrix, comma classification and report. We need this classification and confusion matrix to find the accuracy of our model. Let's define the features on which we need to train our model. So, and the y thing is we need to predict what we need to predict, that is inside the y variable. So drop, and that event, we are going to drop the death event because we do not want this, because we need to predict that thing. So we need to drop it for our training purpose. And def death and event. So here is our x and y. So x is all the columns and except this death event column, and inside y we are having that event because we need to predict that thing, right? So now we can do x train, we can do train test split, and you can also do it by just copying and pasting this thing. Okay, just run this. I'm going to change the test size because as you guys all know, we are having very less number of rows, and if we split the data into 30% of training test size and 70% of our training size, then the model will not have enough data to be trained. Right now we are only giving 10% to our test size, right? And which is okay. Now scalar is equal to min max scalar. Okay, and which means we are normalizing our data. So x train is equal to scalar dot fit transform and x train, and we do not need to fit the data, fit the scalar, sorry, not data, scalar on our test set. So you just need to transform it, transform and x test. Let's run this. Yeah, we are not having errors right now. So x train dot shape, let's check it out. It's 269 and x test, it's 30. So it's okay. We are having 30 rows on test and something like what was that, rows in our training set. So we need to import, like I have trained 3 models on that, which is first one is logistic regression, second one is KNN, and third one is SVM, actually SVC, but the best result I got from the SVC. So let's try SVC, which is support vector machine classification. So from sklearn.svm, from support vector machine, import SVC. Yeah, we are having our SVC. So let's say model is equal to SVC, and what we can do, we can fit the train and x train and y train. So y train, and let's see. So our model is trained. Now we need to predict the predictions. So predictions is equal to model dot predict and x test. So our predictions are here, and if we see for predictions, right? So now we need to compare the predictions. That why we have imported that 2 things, confusion matrix and classification report. So let's copy it and let's print. So confusion matrix for our y test comma predictions, and also the classification report for our y test comma predictions and separate them by this. Okay, we are having accuracy of 80% and we haven't predicted any 0 wrong. I think only 6 we have predicted wrong, so it's not that big deal, right? We are having a good result right now. So it's time to predict if I will survive from a heart disease or not. Like, we need to make our data for myself, right? Or you guys can do for yourself. Let's make some data. So my data is equal to np dot what is this, np dot array, and let's make, but what are the columns? Okay, df dot head. Okay, we are having some columns right there, so it should be two-dimensional array. That's why I'm using 2 square brackets, because our model is trained on 2-dimensional arrays, which is columns and rows. So right now we are saying age, so I'm 19 years old, and what is this? Anemia, a medical condition in which there are not enough red cells in the blood. I don't have it. I don't have any anemia. Okay, 120 creatinine, and what is this? I'm just guessing it. I have 120, and 0 for diabetes because I don't have diabetes, and let's say 30 for ejection fraction. I don't know what is this, and 0 for high blood pressure because I don't have a high blood pressure. And let's say we are having platelets 2. I'm copying it, and let's say 2 to 5 we are having, and what is this? Serum creatinine. Oh, I don't know what is this, so I'm going to put this 1.5. and what else we are having? 140 of serum sodium. Again, I'm just guessing it. Okay, sex. I hope 1 for male. I don't know what is this, 1 is female or 1 is male, but I guess that 1 is male, and 0 for definitely I'm not a smoker, and let's say we are having 100 time, right? We are having my data right now in our hands, so we need to scale that data. So let's say because our model understands the scaled data, so scalar dot transform and my data. Okay, so now our data is scaled and we can predict it. So let's say my prediction is equal to model dot predict my data, and right now we are having my prediction, and I want that computer will speak my predictions. So for that you need to download a library which is a pyttsx3, or you can just download it by saying pip install and pyttsx3, right? Import this library, and let's make a function, and which is def text let's say text to speech and text. And for that you need to do something. You need to define an engine which is a pyttsx3 dot. In it you have to initialize that thing, and now engine dot set property. I'm setting the property because the rate was too high. We need to set it 110. The rate was initially, the rate will be 200, right? If you will not change it. Div engine dot say, and let's say text. Whatever we input, we need to say it text, and at the end engine dot run and wait. So we are having a function which will speak whatever we input, and what we input, result, right? Result prediction. And if prediction is an array, so we are taking the value from that array which is on the 0th index. If prediction is equal to 0, which means text is equal to you are safe. Okay, you are safe. And what we need, text to speech text, and we also need to print that text for our convenience. And else again copy this thing, paste the thing, and just change this thing. You will die soon. Okay, so our function is ready. Let's say result and my prediction, and it is giving us some error, which is text to speech and text to speech. SPEECH. Is there any spelling mistake? No. Then what is name text is not defined. Where is text? Text. Where is text? Okay, guys. I'm really sorry for that.
You will die soon.
I will die.
You will
I
die
don't know why
soon.
I'm laughing, but
You will die soon.
one subscribe
You will
is
die
equal to
soon.
one pray
You
for
will
me.
die-
Anyways, hope you guys are doing good and you like that video, you learned something new, and please subscribe to my channel. Hope we will meet soon in next video. Until then, bye.